might start, right? And an oxidation number, if something's by itself, what is its oxidation number? Anytime anything's by itself, what is it? 0. Does that make sense? Chlorine is by itself. However, if I give you a charge, that's the charge of that compound. So what is the charge of the bottom one? -1. Because I give it to you right there. Does that make sense? Yes? So look for those things on this page. The bottom of it is an answer key. Y'all see the bottom? Yeah. The bottom's an answer key. Obviously, if you just copy straight down, I don't grade this homework. This is purely for your reference. All right? Use it the right way. So also, if I give you a charge, let's say I look at something like SO4, sulfate, and it has an overall charge of -2. And your job is to find the oxidation state of sulfur and oxygen in SO4, right? Well, so you come down and do this, right? Oxygen always has a charge of what? -2. So you're going to put -2 there. That's the easy one. But now, does sulfur have a rule? Does sulfur have a rule? It doesn't. So now you have to do the math. However, should I set this equal to 0? What should I set it equal to? -2. Because that's the overall charge of that compound. Y'all understand that? Yeah. So if I give you an overall charge, that's what you need to use. So what I'm saying is sulfur plus 4 oxygens need to equal -2. So go ahead and find what is sulfur. Go ahead and do that right now. What is the oxidation state of sulfur? This is just my separate example. This is not on your worksheet. Is it on there? Yeah. Okay, well then good. But here we go. Find sulfur. Then I'm doing one for you. So I should see an equation somewhere. Sulfur plus 4 oxygens, each has a -2, has to equal -2. Sulfur minus 8 equals -2. What does sulfur have to be? What does sulfur have to equal? +6, right? So in sulfate, that sulfur carries a +6 charge. Do y'all understand why we set it equal to -2, right? That's kind of the new little curveball for today. Okay? So now what I need you to do is go to the back of that page. So the bottom part is going to be one of the best reviews that we can do kind of over the entire unit. And the top is more oxidation numbers that you can practice with. Part 2 is what I need you to get to. And you're going to add some directions. You're going to write these directions in. Are you ready? If you want to be successful on this test coming up, you need to add these directions and do all of this for letters A through F. Are you ready? So you should be able to identify each one of those reactions. So if you want to do this step by step, step 1 is identify each reaction. Step 2 is to check for completion. Well, what 2 types of reactions do we check for? So in parentheses or somewhere, you might think to yourself, well, I'm only looking for single and double replacements. So if I write SR or DR somewhere, I need to check those, right? If they work, step 3 is to balance them. You should be able to balance all of those equations. Step 4 is you should be able to put all of these equations into word form using solubility. And I'm going to do one for you, and it's going to be a lot easier than what it sounds like right now. So put all of these equations into word form using solubility as well as yields and reacts with or plus. Okay? And I'll do one for you. I'll say one for you.
Solubility, yields, and plus?
Yeah, solubility words. It's not going to be solubility, but I'll do one. It'll be pretty straightforward. Okay? Step 5. You should be able to pick out which element is being reduced, which one's being oxidized, and if it's a redox reaction. That probably should have been first. So you should be able to tell me if it's redox. You should be able to tell me then which one's oxidized and which element's going to be reduced.
Step 5.
Huh?
Step 5.
Tell me if it's a redox reaction. And then if it is, tell me which element's being reduced, which one's being oxidized. And then step 6, you should be able to write the half reaction for what's being oxidized and what's being reduced. Now, if you didn't write that down, you're going to forget some of it, and all of that you're going to be tested over. All of those steps you're going to be tested over. Not this many times and not all in one question. But once again, there's no secrets in here. I don't want you to be blindsided by anything on the test. Every one of those steps, you will be tested and quizzed over coming up. Yeah. To write the half reactions for what's being oxidized and what's being reduced. Write half reactions.
How is it going to look?
I'm going to do one all the way through for you. Actually, 2 of them all the way through for you. All right. So let's do one together with all of those steps in it. And guys, I realize I just that's a tremendous amount of work for one, let alone 6 of them, right? You practice as much as you want to practice, as much as you need to practice. But I promise you that if you don't practice multiple times, you're going to forget some of this stuff, all right? So we're going to start with C, right? So C is this plus chlorine gas yields NaCl solid, right? Yes? So your first step is to identify. What type of reaction is that? That is synthesis. So somewhere you can write synthesis right at the front of on the outside of the letter somewhere. That is synthesis. Leave yourself some room. You got a lot of work to do. Okay. Step 2 is what? Check for completion. Well, the only ones that we're checking for completion are single and double replacement. So do we need to check for completion on this one? No. So we can kind of skip that step. Now we go to 3. What's 3? Balance it. So go ahead. Balance it. Oh, that should be Cl2. That changes things, right? So that should be Cl2. Go ahead. Anybody got the ratio? 2, 1, 2. Any issues with that? Okay, that's step 3. Step 4 is what? Word form using solubility is really the new one, right? We had one question over this the last test before the break, but here we go. This is what you should be able to say out loud and write down because you will have some questions doing this, right? You should be able to say solid sodium reacts with, or plus, you could say plus, you ready? Chlorine gas yields, that's the yields, to make solid sodium chloride. Right? The new part in there is me saying the solubility in the states of matter signs, right? Solid sodium plus chlorine gas yields solid sodium chloride. Any questions there? If you have an AQ in there, you would say aqueous blank, right? That's the only, or liquid blank. Okay? Question? No. So you'll have to do that. The additional thing is putting in the states of matter and solubility when they're up there. Okay? Now, just so you know, there's going to be some examples where I give you all of the reactants and I tell you if it's aqueous or solid, whatever. But in those double replacements, you have to figure out solubility, right? So that would be important to be able to find those the right way so you can write it the right way, right? So that's 4. What's 5? So is this redox? Go back to your notes. Look at that little flow chart. How do I know that it's redox, priest? How do I know it's redox or not redox? How about that?
Not redox, double replacement for neutralization.
What do you say?
Double replacement.
What about double replacement?
And neutralization.
You get that flow chart in your notes? Is it one of those 4? Mm-hmm. Look, what do we label it as? So is it redox?
Yes.
Yes, it is, right? The only time that you would say it's not redox is if it's what? Double replacement or neutralization, right? Neither of those are redox. So that's important to be able to kind of distinguish, okay? So this is redox, which means now you should be able to tell me what's being oxidized and what's being reduced. So down here, what's being oxidized and what's being reduced. Okay? So when I do this, what's my first step? What did we do last week to find out what's being reduced and what's being oxidized? Find the charges, the oxidation states of each one of the elements in this equation. So sodium has what state to it? Careful. 0. Why? By itself. That should help you with chlorine. Is what? Why? Because it's by itself. When I get to sodium chloride, they're not by themselves. So does sodium have a rule? +1, which makes chlorine have to have what? -1. So these are the brand new things that we learned just last class. Okay? So now, when I connect my sodiums here, what has happened to their charges? Has it gotten more positive or more negative? So to get more positive, what has happened to electrons? What's happened to the electrons? So we've lost an electron. Would you all agree with that? To become more positive, we've lost an electron. Well, if I remember oil rig, that L stands for losing. What does the O in oil stand for? Oxidation. Oxidation is losing. Oxidation is losing. So which one's being oxidized? Sodium. If I look at chlorine, chlorine goes from 0 to -1. What has happened to its electrons? Right? So it has gained an electron. Which means in Rig, G stands for gaining. Reduction is gaining. Chlorine has been reduced. Any questions there? Any questions there, right? So you would get a point for that one, and you would get a point for identifying that one, right? Now we need to get into the half reactions. Did we do this last week? I don't think we did in this class, right? So now you need to show me in a chemical reaction what's actually happening to these electrons. Are you ready? So it's going to come off as, or look like this on your paper. So we're simply putting electrons in these equations to show what's happening to them. And just so you know, this gets a little bit detailed. And when I grade it, I have to grade them all the same. I can't grade off of, well, it's close enough, because that's not fair to everybody. Because everybody's close, but I got to be very uniform in my grading. So that means you have to do exactly how I do it up here, right? So here we go. If you're dozing off or anything like that, you're going to completely miss the details to this. This is not a good time for that, right? Not that it ever is, but specifically right now, right? So sodium's my oxidized, chlorine's my reduced. Let's start with the reduction first. So how does chlorine start? What charge does it start with? When I read from left to right, that's how we're doing this. When I say start and end, left to right. How does chlorine end? With a -1. Would you all agree with that? Yes? How did it get from 0 to -1? It gained an electron. Well, if I'm gaining an electron to produce that, there you go. Not too difficult, right? Because I've kind of done the dirty work up here.
Do we need to put 0?
Yes. I will need to see charges. I'll go over this again, but I need to see charges on top. Why? Because look at the math. 0 plus -1 equals what? -1. The math should work out. When I go to my sodium, it gets a little bit slightly more confusing because in a chemical reaction, we cannot put a subtraction sign. We cannot subtract anything.
Okay, this is going to be mathematically.
We can't subtract anything in a chemical reaction. That's just a rule. So you might be thinking, well, with the oxidation, why can't, since it's losing, if I just go sodium 0, because that's what we start as, right? And we need to end at sodium +1. Don't write this part down. I'm going to write it wrong so you can see it wrong. Why can I not say, okay, it lost an electron to give me that? You can't have a subtraction sign in a chemical reaction. So this is wrong. So we need to manipulate it a little bit by saying, think of decomposition. This sodium produces an electron plus that sodium +1. So once again, for oxidation, we've got to manipulate it a little bit so we don't have to put that subtraction sign in. And this half reaction, that was step 6, right? Your half reactions. Okay? Now, just so you know, this part of your steps is going to be, you'll have one on your quiz, you'll have one on your test. Right? And you're thinking, okay, that's a lot of work for one question. It's going to be an FRQ question, and it's going to be worth anywhere from 6 to 8 points. Right? Because you get a point for putting all of these oxidation numbers on your equation. You get a point for determining the correct what's being oxidized and what's being reduced. Yes? You get a point for identifying the correct amount of electrons. And then finally, you get a point for putting your arrows in the right spots. It adds up pretty quickly because it is a lot of work. Okay? So if you choose to skip these and just say, I'm going to take the 0 on this one, that could be 8% of your overall test score. You're down to a 92 if you get everything else right on your test or quiz. You see what I'm saying? Like, these are not, you need to get points somewhere. And as many as possible. Hopefully all of them. But this is also why you need to practice it. It doesn't matter how smart you are or how fast you got this. If you don't practice this multiple times, you're going to forget the format. Okay? Because what's going to happen is, notice how notice how the arrows are in different positions here. Yes? Right? What's going to happen is when you start to do these, or you don't do these until Saturday or Sunday of this weekend, you don't touch them again until then, you're going to start to put something plus an electron yields that, something plus an electron yields that. Notice how these arrows are in the exact same position. That should be a big red flag of like, I've done one of them wrong. You might be thinking, I did one of them right then. I'll take the 50. Like 50% of those points. That's up to you. But if you're looking to get all of them right, that should be a red flag because one of those is going to be wrong. All right? You need to remember that in oxidation, your arrow comes before any of the signs. Okay? Let's go to another one. This time it's going to be a whole lot less of me talking and you doing the work, okay? Let's go to D. You have HBr plus, I think, magnesium, right? There we go, thank you. And it should be aqueous. And this should be a solid. Forms H2 plus MgBr2, I believe.
Can we call an aqueous a solution when we write a reaction?
Okay, say that again.
Can we call an aqueous a solution?
That's fine.
So
For right now, I'd like to say aqueous. It's the same thing, but I want you to use the word aqueous, okay? So, once again, identify. Single replacement. Right away. Second step. Check. Do I need to check single replacement? Yes, I do. Yes, I do. Because I'm trying to check if this metal will bump out that thing that acts like a metal. It's hydrogen. So, will this work? You should be looking at your activity series right now. Will magnesium bump out hydrogen? Well, yes. So this reaction does work. Single replacement. So now you need to do what? If it works, you need to balance it. So go balance it. Raise your hand when you got the coefficient ratio. There you go. What'd you get? 2, 1, 1, 2. Any issues with that? 2, 1, 1, 2? 2, 1, 1, 1?
yes.
Is that better? Okay. So there's your coefficient ratio. Now you should be able to put it into word form. So right now, I need you to say it out loud to somebody. Don't spend time writing it right now. Saying it out loud might be even a little harder than writing it. So go and do that. you say that?
What the?
Put that in the word form.
Oh, no, word form.
So, in order to know if it's not redox, it has to be double.
Double replacement or neutralization.
And then, how do you know if it is? If it's not any
It's
of
not
these-
one of those. That's kind of
Okay.
like, if it's not that, then it is.
Okay.
All right, any volunteers? Come on. There we go.
Soluble hydrobromic plus solid magnesium yields hydrogen gas plus soluble magnesium bromide.
Close. There's a few details. Kingston? It's not. It's ionic. So there's a few things that we should be using the word aqueous.
Bromic acid?
Okay, start over. Go.
Okay, aqueous bromic,
Listen up.
aqueous bromic acid plus solid magnesium yields hydrogen gas plus aqueous magnesium bromide.
All of it but one thing. Hydrobromic. Because it's binary.
For which one?
Your acid, hydrobromic acid.
Okay.
So, to put it all together, you ready? Aqueous hydrobromic acid is added to, plus, or reacts with. All of those are acceptable. Solid magnesium to yield hydrogen gas plus aqueous magnesium bromide. It's a lot. And that's why there's only one or two of those, because it takes you a minute to write all that out. But once again, you will have to write out an equation like that using those solubility signs on your test. Okay?
Aqueous magnesium.
So after that step, what's next? Is this redox? Because it's single replacement? Yes, it's redox. Because it is redox, now I need to say, okay, what's being oxidized? What's being reduced? Right? So what's my step here? What's my first step here? Figure out the charges. Right? Does hydrogen have a rule? Plus 1. So if that's plus 1, bromine has to be minus 1. Magnesium, be careful. Magnesium has a charge of what? 0. Why? By itself. Hydrogen in my products. 0 because it's by itself. Then magnesium bromide. Now, listen, here's a little side note to finding these oxidation numbers. Is this an ionic compound, MgBr2? Guys, those rules that we learned for ionic compounds aren't completely wrong. They're really not wrong at all. Because in ionic compounds, if I just uncrisscross, those are my charges. Okay? So I didn't teach you wrong. I just taught you a few exceptions to what we learned. Okay? So if you uncrisscross these, that works. But also magnesium has a plus 2 charge, which means bromine has to have a minus 1 charge because there are 2 of them. Okay? So now, this one's slightly different because you can only have one reduction, one being reduced and one being oxidized, which means one of those elements doesn't play a factor in this equation. Which one does not change in its electrons? Look at bromine. See how it's exactly the same? which means that thing isn't really used. It's kind of just along for the ride. Now, it's still important, but it doesn't really do much, okay? What we should be looking at is my hydrogen and my magnesium, right? So I'm going to let you go and practice. From there. Okay, if I don't answer it right now, then tell me and we'll visit again. All right, here we go. So once again, guys, like it's just details, like fine details that add up to a lot of points. So here we go. Really pay attention here, right? So hydrogen goes from a +1 to a 0. Did it become more positive or more negative? More negative. So to become more negative, what did it have to do? It had to gain electrons, gain negative things to become more negative, right? Does that make sense? If it gains negative things, it becomes more negative, right? So hydrogen gained how many electrons to become +1 to 0? Just one electron. All right. Then magnesium goes from 0 to +2. So did it gain electrons or lose electrons to become more positive? It lost electrons, it lost negative things to become more positive. So here it lost, I'm going to put 2 electrons. Now, that is probably going to be the biggest hurdle that a lot of you have to get over about this gaining and losing. Okay? Because we are talking about negative particles, it kind of is the opposite of what you might be getting, you might think, right? If you gain electrons, you're more negative. You lose electrons, you become more positive. Okay? So now I come down here. Oxidation is losing. Which one is losing? Which one's losing? What element? Reduction is gaining. Which one is gaining? Which one is gaining? Hydrogen, look, right there. Right? So now when I go to my half reactions, I can start, how does both of them start? Magnesium starts as 0. Hydrogen starts as what? +1, right? How do they both end? Magnesium ends as how? +2. And hydrogen ends as 0. What I did up here is show how we got there. That's why I wrote the electrons in that way. So now we're just bringing all of that down, right? Well, reduction is the easier one because we can just put the plus sign in. Reduction is gaining, so add how many electrons? 1 electron to get that hydrogen 0. Oxidation, magnesium needs to produce how many electrons off of it? 2 electrons will also produce Mg +2.